Today we're going to talk about solving systems of equations. A system of equations is two or more equations that you graph on the same coordinate system. So for our purposes, we're basically going to be looking at where do two lines cross. That's going to be the answer to our system of equations. There are three things that can happen when we solve a system of equations. First, so here are possible answers. First, we might get a point, and that's going to be our intersection point. In other words, it's where the two lines cross. That's going to happen most of the time. The second thing that might happen is we might get no points. And that's going to happen when our lines are parallel. They have absolutely no points in common. Parallel lines never cross. That's the definition of being parallel, and therefore they don't have an intersection. So when we solve that system, it's going to be a null set. Or three, they might actually have all points in common, which implies that they're actually the same line. They might have started out looking different, but when we go to solve them, we find out that they have every point in common, that they're actually the same. So this is our normal situation where we get an x point and we get a y point, and that's the ordered pair that stands for our intersection. This is where we get a null set. So we get to the end of our solving and we get something that doesn't make any sense, like 4 equals 2. This is where we would end up like an identity and we'd get a true statement, like 4 equals 4. And that would tell us that all of the points are actually the same in those two lines. Now, just like there's three different answers, there's three different methods for us solving a system of equations. The first method is the graphing method, which we're not going to review today because you guys already know how to graph lines. The graphing method we don't like to use very much for several reasons. Firstly, because it tends to be more time consuming. It takes longer to figure out to graph the two lines. And secondly, because it tends to be inaccurate, meaning that we rely on us graphing very neatly, and even then, if we aren't crossing at exactly, a point on the graph paper, like if we're at fractional points, then we're just kind of guessing as far as where the intersection point lies. So for that reason, we use graphing as a last resort. It's good to get a ballpark of where our lines cross, what quadrant they might cross in, but otherwise, it's kind of a waste of time. So the two types of ways of solving that we're going to focus on are called substitution and cancellation. So today we'll review substitution, and next time we'll talk a little bit about cancellation. The substitution method has several steps. It starts with being given two lines. Two equations. We're going to choose whichever of the equations looks simpler, and that's up to you. And once we've chosen the simpler looking equation, we're going to choose one of those variables to solve for. Once we've solved for that variable that we chose, we're going to substitute that expression into the equation we didn't use. So we're going to substitute the expression into that other equation, and we're going to solve for that variable. By solving for that variable, it's going to give us either the x-coordinate for the intersection or the y-coordinate for the intersection, depending on which variable you want to solve for. So there is a final step to this. Once we get one of the variables, we only have half of the ordered pair. So then we're going to take whatever we just found and plug it into either equation to solve for the other variable. put it together, our answer is an ordered pair that we label x, y. Whatever our x value is, followed by our y value. So let's go ahead and try an example. So we have these two lines, x plus y equals 6 and x minus y equals 4. We're going to choose one of the equations to work with. In this case, they're both kind of equally simple. I'm going to work with this one, I suppose, but for no real reason. And then we choose one of the two variables, x or y, to solve for. I'm going to solve for x. So that means I add y to both sides. And I get this new expression for x, that x is the same thing as 4 plus y. So substitution is just what the word implies. I'm going to take my new expression and I'm going to place it in instead of x. So I'm going to take this, put it into my other equation where x is. So instead of writing x, I'm going to write 4 plus y. And then everything else about that equation just drops down. Plus y equals 6. Now, combine like terms. 4 plus 2y equals 6. Solve for y. Subtract 4. 2y equals 2. Divide. Y equals 1. So I have half of my intersection point now. I know that the y value for the intersection is 1. So now I take that and I put it back into either one of the equations, or I can put it right back in here, which is what I'm going to do. So x equals 4 plus y, and I know that y is 1. So x equals 5. So the intersection point where these two lines cross is the ordered pair 5, 1. So let's try another one. It's a little more complicated. So we start by choosing the simpler looking equation, which in my mind is clearly this one over here. And then we choose whichever is the simpler looking variable, which is going to be the one without a coefficient. So we're going to go with y. So we solve for y. So negative y equals negative 2x plus 4. Now it's important to remember to make your variable positive. So y equals 2x minus 4. And now I have an expression for y right here, which I am going to plug in place of y into my more complicated looking equation. Remember that everything else about the more complicated looking equation just drops down. So 2x plus 3, instead of y, I'm writing this expression, put it in parentheses, 2x minus 4 plus 12 equals 0. And now I'm going to go through the process of solving for x. Start with distributing. 2x drops down, plus 6x minus 12 plus 12 equals 0. I have 8x. The minus 12 and the plus 12 cancel out. So 8x equals 0. Divide by 8. X equals 0. So far I know half of my intersection point, the x value is 0. Now I take that x equals 0 and plug it back in here. So y equals 2 times 0 minus 4. Remember, 0 times anything cancels it out. So y is negative 4. So the intersection point for these two lines using substitution is the point 0, negative 4. And that is where those two lines cross. Now let's look at an example where they don't cross, an example where they are parallel. in this situation, notice that one of the equations has a variable already solved for. That makes it easy for substitution. I'm going to go ahead, take this, put it in place of y. So the 3x drops down, plus 2 in parentheses. I'm going to put my expression for y equals 6. Now I'm going to go ahead and distribute. Notice the 2's cancel out, leaving me with negative 3x minus 2 equals 6. 3x, take away 3x, those cancel, and I'm left with negative 2 equals 6. Now that doesn't make any sense. Negative 2 does not equal 6. So this would be a no solution, a null set. And what that means is there is no intersection point. So then my answer to this problem, I have to write that the lines are parallel. That tells me that they don't have an intersection point. One more example, so we can see what happens when we have an identity. Okay, so the simpler looking equation, it's hard to tell in this one, but I think I'm going to go with this, because if I add the x over, it'll be all by itself. So there's my expression for x, 4y plus 8 equals x. So I'm going to take that, I'm going to put it in there. Everything else drops down. Go ahead and distribute. Half of 4y is 2y. Half of 8 is 4. Go combine the like terms. The 2y's cancel. 4 equals 4. And that is a true statement. So what this tells me is the lines are the same. So I can write that it's the same line. Or I could say that they share all points. Or I can just write that this is an identity. So that covers with substitution the different possible answers that we can get when we graph a system of equations. You're ready to start some problems.